What if the universe, everything you know, everything you love, the stars scattered like diamonds across the sky, the galaxies spiraling majestically in the darkness, even the very sense of yourself as a conscious being is nothing more than a fleeting ripple in an invisible ocean? Imagine that for all the grandeur and permanence we ascribe to reality, it is simply a shimmer, a glimmer that appeared for no particular reason, destined to vanish again without warning. The idea sounds unsettling, almost absurd, but it is precisely the possibility suggested by modern physics when we look deeply into the strange concept of the quantum vacuum. We are accustomed to thinking of nothingness as an absence, an empty void that contains absolutely nothing at all. But when physicists peer into the smallest scales of reality, they discover that emptiness is not empty. Instead, the vacuum is more like a restless sea, seething with constant fluctuations where particles and their opposites flicker into existence and then vanish almost instantly. These tiny appearances are called virtual particles, and though they may not seem like much, their presence is woven into the very fabric of the universe. It is in this strange backdrop, this so-called nothingness, that is actually full of activity, that our entire cosmos might have been born. Think of it this way. Picture the surface of a vast infinite ocean on a perfectly dark night. To your eyes it seems flat and still, but if you lean closer you notice tiny ripples forming, swelling and dissolving again. Now imagine that one ripple, purely by chance, grows into a wave so large that it breaks free of the surface, towering above the rest. That wave, brief though it may be in the grand scheme of things, would stand out, a temporary creation born from nothing more than random motion. Our universe, according to this line of thought, could be that wave. It is not eternal, not necessary, but accidental, rising from the foam of the quantum vacuum. There is something both terrifying and strangely poetic in this vision. We often imagine the universe as the most solid thing possible, the ultimate foundation of existence. We take comfort in thinking that stars will continue to shine long after our own lives are gone, that galaxies will keep swirling far into the future. But if reality itself is just the product of chance fluctuations, then the universe has no special guarantee of permanence. It is like a soap bubble floating in the air, delicate, shimmering, beautiful, but doomed to collapse back into the thin film from which it came. If that is true, then everything we see is precarious. The mountains that feel eternal, the oceans that seem infinite, even the ground beneath our feet, are all part of a momentary structure that could, on the scale of cosmic time, vanish as suddenly as it appeared. It is almost impossible to imagine this from our human perspective, bound as we are to decades, centuries, or at most millennia. Yet physics invites us to stretch our minds beyond those scales and see reality as it might appear from the outside, from the view of eternity. From that vantage point, 100 billion years is no more than a blink, a flicker in a restless sea. But why does this matter? Why should we care about such an abstract possibility? Because the idea forces us to confront a deeply unsettling truth, that the universe may not have any inherent reason for existing. It might not have been created with purpose, nor follow any cosmic plan. It could simply be an accident, a chance occurrence among countless other possibilities. That notion shakes the foundations of philosophy and faith, challenging the human desire to find meaning in everything. If all of reality is the outcome of randomness, then our lives are not written into the script of the cosmos, but improvised in a fleeting moment of stability. There is also a paradox here, one that almost bends the mind. If the universe is temporary, if it is nothing more than a ripple that eventually fades, how is it possible for us to be here wondering about it? Our very ability to ask the question seems miraculous. Out of all the fluctuations that fizzled out too quickly to form stars, planets, and life, one fluctuation produced a universe stable enough, long-lasting enough for consciousness to arise. And here we are, fragile beings on a tiny world, thinking about the very conditions that allowed us to exist. It is as though the ripple, fleeting as it may be, has become aware of itself before dissolving back into the sea. Take a moment to imagine what this means. If the universe is temporary, then permanence is an illusion. If permanence is an illusion, then everything we cling to, our histories, our civilizations, even our most cherished memories, is suspended on borrowed time. Yet this does not necessarily diminish their value. In fact, the opposite might be true. The fragility of existence could be what makes it precious. Just as a flower is beautiful, precisely because it blooms for only a short while, the universe may be extraordinary because it is not guaranteed to last forever. Its impermanence is not a flaw, but the very thing that gives it meaning. There is a strange comfort in that idea, even if it initially feels bleak. If reality itself is a ripple, then it shares something with us. We too are fleeting, temporary, and uncertain. Our lives are fragile, our bodies transient, our moments limited. To realize that the universe is the same, that it too is vulnerable to vanishing, is to find kinship between ourselves and the cosmos. We are not separate from it. We are its temporary expression, its conscious flicker experiencing itself for the briefest of instants. And so perhaps the question is not whether the universe will vanish, but how we choose to live while it endures. If it is truly just a ripple, then every moment is unique, every breath is unrepeatable, every thought and connection we share is a miracle balanced on the edge of nothingness. To exist at all, even for a moment, is extraordinary. This is where the mystery deepens, because if our universe is only a ripple, we must ask what caused it to rise in the first place. Was it pure chance, a random accident in the seething foam of the vacuum? Or is there a deeper principle, something beyond our grasp that makes universes bloom and fade like sparks? If we are only a bubble in an ocean, what does that ocean truly look like? These questions guide us to the very beginning, to the so-called birth of everything we know, a moment we call the Big Bang. And there the story of this ripple truly begins. For most of modern history, we have treated the Big Bang as the ultimate beginning, the cosmic once upon a time. It is the moment when everything we know burst into existence from an unimaginably dense state, exploding outward into the vast cosmos we inhabit today. But what if the Big Bang was not a singular beginning at all? Not the first page of a story, but simply one chapter in an endless book of fluctuations. What if the birth of our universe was less like a divine spark and more like a random splash in an infinite sea? This possibility, though unsettling, emerges naturally when we begin to think about the universe through the strange rules of quantum mechanics. At the smallest scales, reality does not behave like solid matter does in our daily lives. Instead, it flickers, pulses, and dances with uncertainty. Nothing is fixed, nothing is certain, and every particle is described by probabilities rather than guarantees. This quantum indeterminacy is not confined to particles or atoms. Some physicists suggest that the same principles apply to space-time itself, meaning that the birth of entire universes might be a statistical event, no different in principle from a random particle popping into and out of existence. Imagine a pot of water just beginning to boil. At first, the surface looks calm, but soon little bubbles begin to appear, one here, another there. Most bubbles rise, burst, and vanish within seconds, but once in a while one bubble grows much larger than the rest, swelling until it breaks the surface in a sudden eruption of steam. In some cosmological models, the Big Bang is just such a bubble, a rare fluctuation in the quantum vacuum that expanded instead of collapsing, swelling into an entire universe. This vision is profoundly different from the way we usually picture the Big Bang. We are used to thinking of it as the absolute origin of space and time, a single, unique event. But if the Big Bang is simply the inflation of one bubble in an endless quantum sea, then it is not unique at all. It is one of many, perhaps infinitely many beginnings. Each bubble could blossom into its own universe, governed by its own laws of physics, some expanding like ours, others collapsing almost instantly, still others drifting in strange configurations we can hardly imagine. If that is the case, then our universe is not the story, but a story one among countless others. It is not the grand stage of existence, but merely one stage erected briefly in a theatre of infinite possibility. That idea, while humbling, also enlarges our sense of what reality might be. Instead of a single cosmos, there could be a multiverse, a sprawling foam of universes, each flickering in and out of being like sparks from a fire. But this raises unsettling questions. If the Big Bang is just one fluctuation, then why this one? Why did our bubble expand and endure long enough to form galaxies, stars, and eventually life? The answer, some argue, is simply that it could. In an infinite quantum sea, anything that can happen will happen eventually. Universes like ours will appear, as will universes profoundly unlike ours. We find ourselves in this one not because it was destined, but because it is one of the rare fluctuations where conditions allow beings like us to exist and wonder about it. This way of thinking challenges the way we view beginnings. We crave stories with clear origins, with first causes and definite reasons. But quantum cosmology whispers a different tale, one where beginnings are not singular but statistical, not ordained but accidental. The Big Bang may not have been the first, nor will it be the last. It is just one bubble among an endless froth of possibilities, remarkable to us only because we are inside it. There is something dizzying about this perspective. We humans like to think of ourselves as living in a cosmos with deep meaning, a cosmos that exists for a reason. To imagine that our entire universe is just one fluctuation among many can feel like a loss of significance. Yet it can also be liberating. If reality is far grander than one universe, if it is an infinite ocean where bubbles are constantly forming, then our existence is not less meaningful, but part of a vast, dynamic whole. We are a ripple inside a ripple, a consciousness born from a fluctuation that just happened to last long enough to ask the question. Consider for a moment how different this makes the idea of the Big Bang appear. Instead of a singular moment when everything was created, it becomes an ongoing process, like a cosmic breathing, where universes are constantly inflating into being. Our universe is simply one breath, one expansion, among countless others. It began not because it was destined, but because fluctuations make beginnings inevitable, when time has no end and the vacuum never rests. And yet we cannot ignore the mystery. If our Big Bang was just a fluctuation, then what is the quantum sea it fluctuated from? What is the backdrop that allows universes to bloom like bubbles in boiling water? Is the vacuum truly nothing, or is it something deeper, a hidden foundation of existence that forever gives rise to new realities? As we stare into the depths of this question, we encounter the paradox of modern cosmology. The closer we come to describing the birth of our universe, the more we realize that what we call nothing is not really nothing at all. The Big Bang may not have sprung from emptiness, but from a restless vacuum full of potential, always ready to burst into form. Our cosmos might be just one chapter in an infinite story, its apparent beginning nothing more than a quantum fluctuation, remarkable for being large enough to last. The thought is unsettling, but it is also strangely beautiful. It means that creation is not a one-time miracle locked in the past, but a constant possibility woven into the fabric of existence. The universe is not alone, not absolute, not singular, but part of a greater symphony of fluctuations, each rising and falling like waves in an eternal sea. And so when we think of the Big Bang, we should not imagine it as the ultimate beginning, but as the swelling of a bubble in an infinite ocean. It is not a once-in-history event, but one among countless emergencies, distinguished only by the fact that it gave rise to us. In that sense, the Big Bang is both ordinary and extraordinary, a random fluctuation that could have happened anywhere, anytime, but one that by chance produced the universe we now call home. If that is true, then the Big Bang is not the answer, but a clue, a doorway to deeper mysteries. For if our universe is just a bubble, then we must turn to the sea itself, to the strange vacuum from which such bubbles arise, to understand what reality truly is. And so our journey continues, not with the explosion of everything, but with the question of the nothing that made it possible. When most of us hear the word nothing, we picture emptiness, a vast void stripped of every particle and every trace of matter. We imagine silence, stillness, a blank stage without actors. Yet physics tells us this picture is an illusion. What seems like emptiness is anything but empty. At the smallest scales of reality, the vacuum is not a silent void, but a restless ocean vibrating with ceaseless activity. It is alive with invisible fluctuations, particles and antiparticles that flash into being and then dissolve again like sparks that vanish before you can even notice them. Nothing, it turns out, is full of something. To wrap your mind around this idea, imagine standing on a mountaintop at night. You look up and see the dark sky apparently still and serene. But through a telescope you notice tiny points of light, stars, twinkling galaxies shimmering in the distance. The sky that seemed so quiet is in fact crowded with activity, more alive than you first realized. The quantum vacuum is like that. At first glance it looks like nothing, but under the lens of quantum theory it becomes a storm, a sea of energy, constantly producing brief flashes of matter that appear and vanish faster than a heartbeat. Physicists call these fleeting apparitions virtual particles. They are not like the stable particles that make up our bodies and the stars above us. Instead, they are born from the uncertainty that rules the quantum world appearing, because the vacuum itself is unstable, unable to remain perfectly flat and featureless. These virtual particles arise in pairs, a particle and its antiparticle, which almost instantly collide and cancel each other out. To us, they are invisible, but their effects can be measured. For example, they subtly shift the energy of atoms, a phenomenon detected with remarkable precision in laboratory experiments. Their ghostly presence has real consequences, reminding us that even the deepest void is never truly void. If you want an image, think of the vacuum as a vast orchestra warming up before a performance. At first, it sounds like chaos, random notes, and half-formed melodies. But if you listen closely, there is rhythm, there is motion, there is potential. The universe we live in may be the full symphony that emerged from this background noise. A sudden crescendo rising above the eternal tuning of the instruments. One fluctuation grew louder, expanded, and became everything we know. And when it ends, the orchestra will still be there, humming softly, ready to play again. This idea is difficult to accept because it undermines our intuition. We like to believe that emptiness is absolute, that if you strip away matter, energy, and even light, what remains is a true nothing. But in quantum physics, the very fabric of reality resists stillness. It is like a pond that can never stop rippling, even when no stone has been thrown into it. The ripples are spontaneous, inevitable, and eternal. From this point of view, nothingness is not the absence of being, but the birthplace of being. It is a fertile soil from which universes can sprout like wildflowers. And that brings us to a profound question. What does it mean if the foundation of reality is never still, if there is no such thing as perfect emptiness? It means that creation is not something that happened once long ago, but something that is always possible, woven into the structure of existence itself. The universe may be temporary, fragile, even doomed to fade, but the stage upon which it appears is eternal in its restlessness. Even when everything collapses, the vacuum will still roil with unseen motion, and from it, new fluctuations may rise. There is poetry in this vision. Our universe, vast and magnificent as it seems, may be just a single melody, a brief refrain in a cosmic concert that never truly stops. Galaxies, stars, and planets are notes in a song that swells for a moment before falling silent again. When the music ends, the silence is never total, because beneath it hums the faint vibration of the vacuum, promising that another song might begin. Take a moment to let this sink in. The chair you sit on, the air you breathe, your own body, every bit of matter, is built on a foundation that is not solid ground, but a storm of invisible particles. The reality we trust, the solidity we feel, rests upon something wild and unstable. And yet from this instability structure arises. From restless fluctuations, atoms form. From atoms, stars are born. From stars, planets emerge. And on one such planet, life awakens and becomes aware of the very fluctuations that made it possible. This realization reshapes our understanding of existence. Instead of a universe that is stable and enduring, we inhabit one that is perched precariously on the restless stage of the vacuum. Our world is not a fortress against nothingness, but a ripple within it. One of countless ripples that appear and vanish. Far from being empty, the void is the most creative place imaginable. It is the canvas upon which universes are painted, erased, and painted again. But if the vacuum never rests, if it is always in motion, then perhaps our universe is already doomed to fade. Fluctuations gave birth to it, and fluctuations may one day unravel it. Just as a note fades back into silence, so too might our cosmos fade into the background hum from which it came. What feels eternal to us may be only temporary in the larger scheme of things. There is a strange tension here between awe and unease. On one hand, we marvel at the idea that reality is born from nothing, that what appears to be emptiness is secretly the richest source of possibility. On the other, we are humbled by the thought that everything we know, even the universe itself, may be just a passing vibration, destined to vanish back into the silence of the vacuum. And yet perhaps that very fragility is what makes the universe meaningful. If everything were permanent, nothing would be precious. The fact that existence is delicate, born from fluctuations and destined to end, means that every moment is a gift. To be alive, to think, to wonder, is to experience a miracle of impermanence. So the next time you hear the word nothing, remember that it is not empty at all. It is a seething ocean, a restless background, the womb of universes. Our cosmos is one brief melody in a symphony without end. One day the song will end, but the silence will not be silence. It will be a pregnant pause waiting for the next crescendo. And if our universe is just a temporary note in that infinite song, we must ask, is it already fading? Is the great music of creation counting down toward a final rest? If the vacuum is never still, perhaps the stage is already being set for the day when our cosmos dissolves, when the melody of existence falls quiet and the endless hum of nothingness takes over once more. Imagine holding a grain of sand in your hand. It looks so small, so fragile, and yet it is made of billions upon billions of atoms. Inside those atoms sit protons, tiny particles that we tend to think of as the bedrock of matter, the unbreakable foundation upon which everything is built. For most of history, scientists assumed protons were eternal, that once formed they would never fall apart. After all, how could the universe itself exist if its most basic building blocks were temporary? But modern physics whispers a different, more unsettling story. The proton, it seems, may not be immortal at all. Some of the most ambitious theories in particle physics, often called grand unified theories, suggest that protons, despite their stability, are doomed to decay. Not tomorrow, not in a million years, but eventually after an almost incomprehensible amount of time. The numbers are staggering. A single proton could last for at least 10 to the power of 34 years. That is 1 followed by 34 zeros, far longer than the current age of the universe, which is only about 13.8 billion years. But even if protons live that long, they are still not eternal. Their eventual decay would set an ultimate clock on the existence of ordinary matter, a quiet countdown ticking away in the background of reality. To grasp this, imagine a beautiful mural painted on the wall of a temple. For centuries it looks untouched, the colors bright and the shapes vivid. But given enough time, moisture seeps in, cracks form, and the pigments begin to fade. At first the changes are so slow they are imperceptible, but the process is relentless. One day, no matter how beautiful the mural once was, it will vanish. That is what proton decay would mean for the universe. Every atom of matter, every structure built from those atoms, every mountain, star and cell will eventually crumble at the most fundamental level. This decay would not be dramatic like an explosion. It would be silent, invisible, and unbearably slow. One by one, protons would transform, breaking apart into lighter particles, releasing faint whispers of energy as they do. Over the course of unimaginable spans of time, entire galaxies would dissolve into nothing but radiation and a thin mist of exotic particles. The universe would not end with a bang, but with a slow, inexorable fade into darkness. It is hard to picture timescales like these, but let us try. If you compressed the entire age of our universe into a single year, the lifetime of a proton would stretch into thousands upon thousands of such years. Imagine watching fireworks only to learn that their sparks will continue to glow faintly for millennia before they finally vanish. That is how long protons can endure. Yet, endurance is not the same as immortality. Scientists have searched tirelessly for signs of proton decay. Giant underground detectors filled with vast tanks of pure water or liquid scintillators have been built to catch even the faintest evidence of a proton falling apart. They wait in darkness like fishermen casting nets into a silent sea, hoping to glimpse a single rare event. So far, no conclusive evidence has been found, but the very fact that we are looking is telling. It shows that physicists take seriously the possibility that the universe itself may not be permanent, that the clock may be ticking even if we cannot hear it. If protons do decay, the implications ripple far beyond particle physics. It means that nothing we know is truly eternal. The stones that make mountains, the iron that makes blood, the carbon that makes life, all would be doomed to disintegrate. The universe in this view is like a grand cathedral built from sand. For now, its arches soar and its windows gleam, but the grains are already slipping away, and the collapse, though distant, is inevitable. There is a certain melancholy in this vision. Instead of being torn apart in some cataclysmic finale, the cosmos would simply fade. It would lose its stars, its galaxies, its light, until only emptiness remained. Imagine walking into a once bustling city that has been abandoned for centuries. The buildings are crumbling, vines creep over broken walls, and silence fills the streets. The beauty is gone, but so is the violence. Only decay remains. And yet there is also something strangely comforting in this idea. The end, if it comes this way, would not be violent or chaotic, but gentle. A slow retreat into quietness, like a fire burning low until only embers remain. From a human perspective, the timescale is so vast that it borders on eternity. To us, the universe would appear eternal because no individual, no civilization, no species could ever live long enough to witness its fading. But from the perspective of infinity, even this slow decline is just another step in the dance of existence. Take a moment to reflect on what this means. The chair beneath you, the walls around you, the ground under your feet, all rely on protons holding fast. Their stability gives us a sense of permanence, a feeling that the universe is built on solid ground. But if protons are destined to decay, that stability is an illusion. Even the most solid rock is only temporary scaffolding destined to crumble away in the fullness of time. The permanence we feel is only an interlude before the music fades. Some thinkers have compared this vision to the fading of memory. A photograph left in sunlight does not vanish suddenly, but over years its edges blur, its colors fade, its details dissolve until only a faint outline remains. The universe in its twilight might be like that. A fading memory of itself, barely recognizable but still carrying the ghost of what once was. But if the proton is not eternal, if it carries within it the seeds of decay, then the universe is not timeless. It has a built-in countdown, a silent metronome keeping track of the ages. And even if that countdown stretches into unimaginable spans of time, the fact that it exists at all changes everything. It means we are living in a universe that is temporary, fragile, and fleeting, no matter how vast it seems. And that fragility forces us to confront deeper questions. If the universe is destined to fade, what does it mean for meaning itself? Are beauty, love, and thought diminished because they will one day be erased, or are they more precious because of it? Perhaps transience is not a flaw, but the very essence of existence, the reason moments matter. If protons were eternal, then life might be endless repetition. But because they are not, every moment is unique, a spark in the darkness. Still, the thought lingers. If protons decay, then the universe carries within itself the promise of its own end. It is a soft ending, yes, but an ending nonetheless. And if this is true, we must ask what other dangers might lurk in the fabric of reality. Are there ways in which the cosmos could unravel, not in aeons of slow fading, but suddenly catastrophically in the blink of an eye? For there is a darker possibility, one even more unsettling than proton decay. a scenario in which the very vacuum of space itself collapses, rewriting the rules of physics in an instant, wiping away everything without warning. If protons whisper of a slow fading into emptiness, the vacuum itself may harbor the threat of a sudden and total silence. There is a certain kind of fear that is deeper than thunder, deeper than fire, deeper than the sight of an asteroid falling from the sky. It is the fear of silence. Not the kind of silence we experience at night when the world goes to sleep, but a silence so complete it erases even the possibility of sound. A silence in which not just life, not just planets, not even galaxies remain. Only nothing. Physicists have a name for the nightmare that could bring such silence: vacuum decay. It is the possibility that the very fabric of reality, the ground beneath existence, is not as stable as it seems. When we hear the word vacuum, we tend to picture emptiness, a clean void where nothing stirs. But in physics, a vacuum is more than the absence of matter. It is a state of energy, a configuration of the quantum fields that fill all of space. The vacuum we live in feels stable, reliable, even permanent. But quantum mechanics, that mischievous trickster of science, tells us it may not be. Our vacuum might not be the lowest possible energy state, but only a false vacuum, a precarious plateau, balanced for now, but doomed to collapse eventually into something deeper and more stable. If that collapse were to happen, the consequences would be instant and absolute. Somewhere, without warning, a tiny bubble of true vacuum could form. Within this bubble, the laws of physics as we know them would be rewritten, because the very quantum fields that define particles, forces, and interactions would shift into new patterns. That bubble would expand at the speed of light, unstoppable and undetectable, until the moment it arrives. Every atom, every star, every thought would vanish, not torn apart or burned, but simply rewritten into a reality that no longer supports what we know as matter. This is not a gentle fading like the slow decay of protons. It is annihilation in pure silence. No warning, no chance of survival, not even a moment to realize it has begun. One instant you are here thinking, breathing, existing, and the next there is no you at all. Not even ash, not even memory. Just absence. A cosmic curtain falling without applause. It is difficult to grasp the horror of such an idea, because our minds are built to imagine endings in terms of time. We think of fires dying out of civilizations, falling of stars collapsing, all of which unfold across some span of seconds, years, or millennia. But vacuum decay allows no such grace. It is instantaneous from the point of view of anything inside the doomed universe. No time to fear, no time to regret. It is perhaps the most merciful and most terrifying end imaginable. How could such a thing be possible? The idea arises naturally from the mathematics of quantum field theory. Fields like the Higgs, which gives particles their mass, may not sit forever in their lowest energy state. Instead, they might rest in a local valley, a good enough minimum, while somewhere further down lies the true abyss of stability. Our universe in this picture is perched in a false resting place, like a ball trapped in a shallow dip on a hillside. For now it lingers there, but with enough time through quantum tunneling, it could suddenly slip free and roll into the deeper valley below. That slip is the moment of collapse. Physicists do not know if our vacuum is false or true. The answer depends on measurements of fundamental constants like the mass of the Higgs boson and the top quark. Current data suggest we may live precariously close to the edge, teetering in a state of metastability. Not doomed, not safe, just balanced between, like a tightrope stretched over infinity. If vacuum decay were to begin, nothing could stop it. The expanding bubble would not be slowed by gravity, not deflected by matter, not weakened by distance. It would cut through planets, stars, and galaxies without resistance, because it is not a force spreading through space. It is space itself being rewritten. Even light would not outrun it. By the time the edge of the bubble reached you, you would already have ceased to exist. What would remain after such an event? That depends on the nature of the true vacuum. Perhaps the laws of physics there allow no structures, no chemistry, no stars. Perhaps space itself collapses into nothingness, leaving no dimensions, no time, Or perhaps a new cosmos, alien and unfamiliar, takes shape governed by constants so different that nothing we recognize could form. Either way, there would be no trace of what came before. The library of the universe, every page, every word, every letter, burned away without a sound. There is a strange irony here. For all its terror, vacuum decay is the kind of apocalypse you should not lose sleep over. If it happens, you will never know. There is no suffering, no anticipation, no apocalypse to witness. The moment is gone before it can even be perceived. It is not an ending we would experience, but rather the absence of experience itself. To us, it would feel like nothing at all, and yet the concept has a chilling weight. It forces us to recognize how fragile our existence is, not just in the face of asteroids or dying stars, but at the level of the very stage upon which existence plays. We tend to believe the rules of physics are eternal, that the fabric of reality is immutable. But vacuum decay reveals that even the rules themselves may be temporary, vulnerable, and subject to change. To imagine this picture, a play unfolding on a stage. The actors move, the lights shine, the story advances. Normally, when a play ends, the curtain falls and the actors leave. But in vacuum decay, it is not just the play that ends. The stage itself vanishes, the lights disappear, and the very idea of performance is erased. Nothing is left to recall that it ever happened. This possibility transforms the way we think about permanence. We may comfort ourselves with the thought that even if life ends, the universe will continue, that stars will shine for billions of years, that galaxies will dance through the void. But vacuum decay tells us not to be so certain. The cosmos itself has no guarantee of survival. It too rests on precarious ground. And so we find ourselves caught between two visions of cosmic death. On one side, the slow, fading decay of protons, a long twilight of dwindling stars and cooling embers. On the other, the sudden and absolute silence of vacuum collapse. One is a melancholy sigh stretched across eternity, the other, a single sharp note of finality. Both spring not from myth or imagination, but from the same principles of quantum mechanics that describe the ordinary world around us. It is strange, almost poetic, that the same equations that explain how electrons orbit atoms, how light shines, how matter resists collapse, also hint at the possibility of the universe's erasure. Out of familiarity, out of the rules that shape our daily existence, comes the suggestion of our ultimate annihilation. But this should not only frighten us, it should also remind us of the extraordinary privilege of being here at all in this fragile vacuum that holds, for now in this moment when the laws of physics align to permit stars life and thought. The possibility of silence only makes the present symphony more beautiful. If the stage is temporary, then every line of the play, every note of the song, every flicker of consciousness is all the more precious for being fleeting. And so we return to the unsettling thought: the end may not come with warning or with time to prepare. It may not even come with a whisper. It may come with nothing at all. The only certainty is that whatever happens, it will be born from the same quantum principles that gave us everything in the first place. Imagine for a moment a box. Inside the box is a cat along with a contraption that has a 50% chance of releasing poison. Until you open the box, you cannot know whether the cat is alive or dead. In the strange, unsettling logic of quantum mechanics, before the box is opened, the cat is not in one state or the other. Instead, it is in both states, simultaneously alive and dead, intertwined in what physicists call a superposition. This is the famous thought experiment of Schrödinger's cat, and while it may sound absurd, it perfectly captures the bizarre nature of the quantum world. Now take that thought experiment and stretch it to its most mind-bending extreme. If a cat can exist in two states at once, if an electron can be here and there spinning up and down simultaneously, then why stop at small things? Why not apply the same logic to everything? Why not to the universe itself? Could the cosmos, all of reality, be in a kind of superposition, existing in multiple states, multiple versions of itself, until some cosmic observer collapses it into one? This idea is not as far-fetched as it sounds. At the heart of quantum mechanics lies the wave function, a mathematical description that captures every possible outcome for a system. An electron's position is not a fixed dot, but a wave of probabilities, a ghostly cloud of possibilities that only becomes definite when measured. The act of observation in some interpretations is what forces the universe to choose one outcome over the others. But until that moment, all outcomes exist in superposition, waiting entangled both real and unreal. So what happens if you apply this reasoning to the entire universe? The universe too could be described by a wave function containing all possible histories, all possible futures, all possible laws of physics. In this sense, our reality may be like a single thread pulled from a vast tapestry of potentialities. We live in one outcome, but there are countless others branching, coexisting just beyond reach. We are like the cat alive in this box of reality, but dead or something else entirely in another. The implications of this are staggering. It suggests that what we call reality is not unique. Our universe may be only one branch of a cosmic superposition, one solution among infinitely many. In one branch, galaxies form and stars ignite. In another, gravity might be stronger or weaker. Atoms might never form. Time itself might flow in a way incomprehensible to us. Somewhere in that forest of universes, there might be a version of you who made different choices, lived a different life, or never came to exist at all. The strangeness deepens when we consider how this superposition might evolve. In quantum mechanics, when a particle interacts with its environment, the possibilities split and the wave function branches. Applied to the universe, this process, sometimes described in the many worlds interpretation, implies that with every quantum event, reality divides. Every time a photon hits a surface, every time a particle decays, the universe forks, creating multiple versions that go their separate ways. What we experience as a single continuous reality might actually be the faint echo of an unimaginable branching structure, a tree of universes splitting endlessly. Of course, this raises profound questions about what it means for something to exist. If multiple versions of the universe are real, then existence itself is not a singular linear path, but a vast cloud of possibilities. Our sense of solidity, of uniqueness, might just be a kind of illusion, a byproduct of occupying one particular branch while the others remain hidden from our awareness. In this way, quantum mechanics does not just describe particles and forces. It challenges our most basic assumptions about reality itself. And yet there is something oddly comforting about this vision, unsettling as it may be. If reality is a branching tree of possibilities, then perhaps nothing is ever truly lost. Every choice, every chance, every roll of the quantum dice is realized somewhere. The universe is not a fragile, singular thing, but a vast multiverse of overlapping songs, each note played, each path explored. You may have walked down this road, but in another branch you walked another. In one universe the cat lived, in another it died. Both stories exist, both are true, both are woven into the grand wave function of reality. But then we must ask, why do we experience only one version? Why does reality feel solid, definite, consistent? The answer may lie in a phenomenon called decoherence. When quantum systems interact with their environment, their delicate superpositions quickly dissolve into outcomes that appear classical, fixed, unambiguous. For small systems like particles, superpositions can be sustained. But for larger, more complex systems, cats, people, planets, universes, the sheer number of interactions forces the wave function to branch irreversibly. Each branch becomes isolated, unable to interfere with the others. To us, it feels as though only one outcome has occurred, but in truth the other outcomes continue invisible and inaccessible, like parallel rivers flowing beyond the horizon. The thought that our universe might be one branch of a superposition pushes us to reconsider our place in the cosmos. Perhaps the Big Bang itself was not a singular event, but a quantum fluctuation that split into countless beginnings. Perhaps every law of physics we know is only local to our branch while others evolve differently. This is not merely speculation for science fiction. It is an extension of the principles of quantum mechanics, principles that have been confirmed again and again in experiments with particles too small to see but too real to deny. So we are left with an extraordinary possibility. Reality as we know it may not be the only reality. We live in one unfolding branch of the universal wave function, a single melody in an infinite symphony. Somewhere else unseen and unreachable, the music plays differently. Other universes hum their own songs, guided by different notes, different rhythms, perhaps even different instruments entirely. To grasp this is to realize that the mystery of existence runs deeper than we ever imagined. It is not just a question of how the universe began or how it will end, but of what the universe even means. Is it one or many? Is it stable or forever branching? Are we singular beings or shadows in a greater structure of possibilities? The thought is dizzying, like staring into a mirror that reflects not just yourself, but infinite versions of yourself, each slightly different, each walking a different road. But within that dizziness there is also wonder. For if our universe is only one of many, then existence is richer than we can possibly conceive. It means that reality itself is more vast, more mysterious, more alive than our single thread could ever suggest. And so we arrive at the question that naturally follows. If our universe is only one branch, one possibility in a quantum forest of possibilities, then what lies beyond? Could there be infinite universes, each with their own laws, their own histories, their own destinies? Could reality itself be a multiverse, a boundless ocean, where every possibility not only exists but thrives? The cat in the box may have been only the beginning. The real question is, how big is the box, when the box is the universe itself? Imagine standing at the edge of a vast infinite ocean, its waves stretching beyond the horizon, each crest and trough hinting at hidden depths. Now imagine that instead of water, this ocean is made of quantum fields, restless and turbulent, forever roiling with fluctuations. Out of this churning sea bubbles form rise, and sometimes burst, each bubble containing within it a universe. Some are short-lived, dissolving almost as soon as they appear. Others expand, stabilizing just enough to develop their own internal laws, structures, and histories. We may be living in one such bubble, our entire reality floating in a foam of countless other universes, each with its own peculiar rules. This is the idea of the multiverse, and it transforms our understanding of existence. In this picture, the Big Bang that gave rise to our cosmos was not a singular, unrepeatable event, but one of many such bubble inflations occurring within an infinite quantum sea. Our universe is not the universe, but simply one among billions or trillions, perhaps an uncountable number, each an island of order in the stormy expanse of possibility. Inside our bubble, the constants of physics seem perfectly tuned for stars to shine, planets to orbit, and life to evolve. Gravity is strong enough to hold galaxies together, but not so strong that everything collapses. The electromagnetic force allows atoms to form chemistry to thrive and biology to unfold. To us, these constants feel inevitable, almost natural. But in the multiverse view, they are anything but. They are just local conditions, quirks of our bubble's birth. In another bubble, gravity might be crushingly strong or vanishingly weak. In yet another, protons may not be stable, or atoms might never bind together. Most bubbles, in fact, may be barren, lifeless, chaotic expanses, where complexity never takes root. This perspective reframes one of humanity's oldest questions: why are we here? If the universe is singular, the apparent fine-tuning of its laws seems mysterious, even uncanny. Why should the numbers be so perfectly arranged for life? Why should the cosmic dice have rolled just the right way? But if the multiverse exists, then the question shifts. It is not why are the laws of physics what they are, but why do we find ourselves in this particular bubble? The answer in that case is almost tautological, because only in such a bubble could beings like us emerge to ask the question. It is a sobering but strangely liberating thought. Our existence may not be the product of design or destiny, but of selection. Out of an infinite foam of bubbles, we inhabit one where the conditions happen to be right, not because they were meant to be, but because in all the others there was no one to notice. This is sometimes called the anthropic principle, the recognition that observers can only exist in universes where observation is possible. From this angle, our cosmos is not special in itself, only in relation to us. It is one bubble among many, yet the only one we could ever know. Still, the implications stretch far beyond philosophy. If other bubbles exist, then the space beyond our observable universe is unimaginably rich. Entire galaxies, alien laws of physics, and exotic forms of reality might populate the cosmos just out of reach. Some universes may expand forever, growing cold and diffuse. Others may collapse back into nothingness. Some may teem with life, though utterly unlike ours. Others may remain sterile, vast deserts of empty space. The multiverse, if real, is not just a theory of physics, but a vision of abundance, a cosmic wilderness, where every possibility is realized somewhere. And yet this idea raises profound mysteries. If the multiverse is real, can we ever detect it? Our bubble is sealed off by its own space-time, expanding too quickly for signals to cross into others. Collisions between universes, if they occur, might leave faint scars on the cosmic microwave background, subtle imprints of a neighboring bubble brushing against ours. Physicists have searched for such patterns, though. So far, the evidence remains tantalizing but inconclusive. Perhaps the multiverse will forever remain a matter of inference and imagination, hinted at by mathematics, but never directly observed. Even so, the concept reshapes our sense of scale. For centuries, humanity has faced the humbling realization that we are not at the center of the cosmos. The Earth orbits the Sun. The Sun is one star among billions. Our galaxy is one among trillions. But the multiverse goes further, still suggesting that even our universe is not central, not unique, but just another bubble drifting in an endless sea. The hierarchy of humility descends one level deeper, reminding us again that reality is larger, stranger, and more indifferent than we once believed. And yet within this vastness, something remarkable occurs. In one bubble, amidst the right balance of forces, life arises. Out of stardust and chemistry, consciousness emerges, capable of reflecting on its own existence. This fragility, this improbability, does not make our place insignificant. On the contrary, it highlights the preciousness of the bubble we inhabit. To exist at all within a universe that allows complexity is a miracle of statistical fortune. Whether or not other universes teem with life, ours is the one we know, the one that nurtured us, the one whose story we are part of. So the multiverse, while humbling, is also strangely affirming. It tells us that we are not inevitable, not guaranteed, but rare. And in rarity there is beauty. Our bubble is not the only one, but it is ours. A fragile world of stars and oceans, laughter and sorrow, fragile beings pondering eternity while suspended in a thin film of quantum foam. This vision invites both awe and unease. Awe at the immensity of reality which refuses to be confined to a single universe. Unease at the recognition that our place is contingent, that the laws we take for granted are local accidents in an infinite lottery. It is a reminder that the cosmos is not designed for us yet. We are here nonetheless, clinging to one bubble, in the foam asking questions that stretch beyond it. And so we come to the next mystery. If we are but one bubble in a vast sea, then how could such fragile, intricate phenomena as life arise from the chaos? How can matter emerging from blind quantum fluctuations arrange itself into stars, planets, cells, and minds? If the multiverse is the stage, then life is the rare performance that brings meaning to it. The question becomes not only why we are in this bubble, but how life against all odds bloomed within it. For as long as human beings have looked up at the night sky, there has been one question that seems to hover above all others, older than science, older even than philosophy. It is a question whispered by poets and pondered by mystics carved into temple walls and murmured in quiet despair. Why is there something instead of nothing? Why should existence itself be the case at all when nothingness seems so much simpler, so much cleaner, so much more natural? At first glance, nothing feels like the default state. Imagine stripping away every planet, every star, every galaxy. Remove the atoms, then the particles, then even the fields that weave through space. What could remain but an absolute void, silent and eternal? Many traditions have pictured this kind of primordial nothingness, an empty canvas awaiting creation. Yet modern physics whispers a different story, one that unsettles our intuitions. According to the strange logic of quantum mechanics, nothingness may not be stable. The vacuum, instead of being a blank stage, seethes with invisible energy. Like a pot of water that refuses to stay calm, it bubbles with fluctuations, particles flickering into and out of existence, ephemeral but real. In such a restless backdrop, the emergence of something may not be a miracle at all, but a statistical inevitability. Some physicists suggest that this is the answer to our ancient question: why is there something rather than nothing? Because nothing is impossible. The laws of quantum mechanics demand activity, unpredictability, a restless froth where possibility cannot be suppressed. If the vacuum is destined to fluctuate, then given enough time, or perhaps timelessness itself, structures will emerge. From tiny transient sparks of order, whole universes might inflate, expanding into stable realms where particles can combine, stars can burn, and life can wonder about its improbable fortune. Existence in this view does not require a cosmic architect or an ultimate purpose. It is not the product of design but of probability. We are here because the dice of the quantum world rolling endlessly eventually produced a winning throw. This way of thinking reframes reality itself as a kind of lottery. Imagine a cosmic slot machine, its reels spinning endlessly, symbols flashing in all directions. Most outcomes are meaningless, chaotic, ephemeral, but every so often the reels align in just the right way, producing a jackpot, a universe with stable particles, a universe with chemistry, a universe with life. We live in the aftermath of one such improbable alignment, not because it was destined, but because it happened, and here we are to notice. The odds may have been astronomically low, but in an infinite sea of attempts, even the rarest outcomes become inevitable. To many, this explanation feels unsatisfying, even unsettling. To say that we exist simply because probability allowed, it feels like dodging the deeper mystery. After all, where did the laws of probability come from? Why is there a quantum vacuum at all, seething with fluctuations rather than a genuine nothingness in which no law, no mathematics, no possibility exists? The question shifts but does not disappear, echoing further down into the darkness. Yet others find in this view a kind of profound elegance. Instead of a universe that demands a creator or a hidden purpose, we find a reality that emerges naturally, inevitably, from the restless bedrock of quantum law. Nothingness, it seems, is an illusion. The universe is not improbable. It is unavoidable. And if that is true, then our own existence carries a peculiar flavor. We are not here because we were meant to be, nor because the cosmos conspired to produce us. We are here because in the ceaseless churning of possibility, one arrangement produced atoms that could form molecules, that could form cells, that could eventually think and feel. Life in this vision is not the crown jewel of creation, but a byproduct of chaos, a lucky streak in the great casino of reality. It is at once humbling and awe-inspiring, reminding us how fragile and contingent our presence truly is. The implications ripple outward. If everything exists because probability makes it possible, then perhaps every possible configuration of reality has in some sense occurred or will occur. Every set of physical laws, every kind of universe, every improbable alignment. This connects naturally with the multiverse idea, in which our universe is just one outcome among countless others. In that broader picture, the fact that we inhabit a universe suitable for life is no more remarkable than finding ourselves holding a winning ticket in a game where infinite tickets are drawn. Someone somewhere had to win, and in this case it happens to be us. Yet, even as physics offers this probabilistic answer, it leaves us with a philosophical riddle. If existence is a matter of chance, does that make it less meaningful? Some argue that it does that without intention or design. Life is stripped of ultimate purpose. Others see it differently. They argue that meaning is not handed down from the structure of the cosmos, but created from within by conscious beings capable of reflection. If we are here by chance, then our stories, our loves, our struggles, and our triumphs are all the more precious precisely because they were not guaranteed. The fragile flame of consciousness flickers against the void, not because it had to, but because improbability allowed it. In that improbability lies beauty. This view also highlights the razor's edge on which our existence balances. Small changes in the laws of physics, in the values of fundamental constants, could have rendered our universe barren. If protons were unstable, if the electromagnetic force were slightly weaker or stronger, if the expansion rate of the cosmos were just a fraction different, then stars would not shine, atoms would not bind, and life could never awaken. To live in such a finely tuned bubble is to be reminded daily of our improbable luck, as though we had stumbled into the one habitable clearing in an endless desert. Of course, the lottery metaphor has its limits. Chance alone does not explain everything. Probability requires a framework, a set of rules according to which outcomes are possible. The question of why quantum mechanics exists at all, why there is a law that permits fluctuations and not sheer emptiness, remains a mystery that science has not yet unraveled. Some thinkers suggest that this ultimate question may forever elude us, that asking why there is something rather than nothing is like asking what lies north of the North Pole. Perhaps existence is simply the ground floor of reality, the fact upon which all else is built. And yet, even if the deepest mystery remains unsolved, the probabilistic view of existence reshapes our place within the cosmos. It casts us not as the intended outcome of a grand design, but as improbable survivors of an infinite lottery, ephemeral creatures who somehow became aware of their own fragility. That awareness itself is staggering. Against all odds, atoms assembled into beings capable of contemplating the odds. Out of chaos, consciousness arose, and with it, the ability to turn the question of existence back upon itself. This brings us naturally to the next question, one that cuts even deeper. If the universe itself is a lucky outcome of quantum chance, then what about consciousness? This most intimate and elusive phenomenon, the shimmering quality of awareness, may not be a miracle of purpose, but a byproduct of improbable arrangements of matter. If existence is a lottery, is our very sense of self nothing more than another winning number, a fragile spark briefly burning in the great randomness of being? For all our discoveries about the cosmos, there remains one mystery that overshadows the rest, a puzzle so intimate and yet so elusive that it feels almost untouchable. We can chart galaxies billions of light years away, we can measure the faint afterglow of the Big Bang, we can theorize about the fate of matter trillions of years in the future. And yet the one thing we cannot fully explain is happening right here behind our eyes every waking moment. Consciousness, awareness, the strange, shimmering fact that the universe is not only unfolding, but that it knows it is unfolding because at least some part of it in us is aware. This is where physics and philosophy collide. The question is not only how did matter arrange itself into stars, planets, and life, but how did those arrangements give rise to experience? At some point in the restless turbulence of quantum fluctuations, order-formed molecules combined, and Act II, eventually, cells arose. Over eons, evolution shaped those cells into nervous systems of increasing complexity. Out of the firing of neurons, out of chemical signals leaping across synapses, somehow there emerged something more than matter. There emerged the first flickers of sensation of awareness of what it feels like to exist. From there, a long chain of developments eventually produced creatures who could not only survive but reflect. They could ask questions, tell stories, dream of futures, and contemplate the void. Some scientists believe consciousness is not mystical at all, but a natural emergent property, like the way liquid water flows from countless individual molecules of H2O. None of those molecules is wet on its own, yet put enough of them together under the right conditions, and the quality of wetness appears. Likewise, no single neuron is conscious, but in the right arrangement with the right density of connections, the property of awareness emerges. The universe then, in one of its infinite experiments with complexity, stumbled upon a structure capable of knowing itself. out of the blind play of chance, matter arranged into mind. This idea has staggering implications. If consciousness is simply what happens when matter reaches a certain level of complexity, then our awareness is not an exception but a possibility, latent in the fabric of the universe itself. The cosmos did not just produce galaxies and stars, it produced observers, small islands of reflection scattered across the darkness. Perhaps wherever conditions are right, awareness blooms as natural in its way as the growth of crystals or the formation of planets. And yet the fact remains that it is incredibly rare, at least from our vantage point. For most of the universe, silence reigns. For most of time, nothing stirs. Against that vast stillness, consciousness appears as a fragile spark like a firefly in a forest at night. And if the universe itself is temporary, if protons decay and stars burn out, then what does that mean for this spark? It means consciousness may be nothing more than a fleeting moment of self-awareness in the grand sweep of existence. Imagine a dark, unbroken ocean. For a moment, a single wave rises, catches the light, glitters with brilliance, and then collapses back into the depths. That is what awareness might be, a brief flare of the cosmos looking at itself before silence returns. In this sense, our thoughts, our memories, our very sense of self are not permanent possessions but temporary gifts borrowed from the universe's restless energy. There is a haunting beauty in this fragility. If everything ends, then each instant of awareness is infinitely precious. Every joy, every sorrow, every act of kindness, every question we ask carries weight because it will not last. We are not eternal observers but momentary ones, and in that moment we give the universe something extraordinary, a voice. The stars burn without knowing, galaxies collide without intention, black holes devour without care. But through us, the cosmos has found a way to say, "I exist, and I know that I exist." This line of thought leads to profound philosophical questions. Is consciousness a fundamental feature of reality woven into its very fabric? Or is it merely a rare byproduct of complexity, a cosmic accident that could easily have never been? Some thinkers lean toward panpsychism, the idea that awareness is not an emergent property, but an intrinsic aspect of the universe, present in some form at every level, even in the most basic particles. Others argue it is a high-level phenomenon requiring vast networks of information processing, making our own experience something almost unimaginably rare. Wherever the truth lies, the fact that we can ask the question at all is astonishing. Of course, this view forces us to confront an uncomfortable possibility. If consciousness is just a chance outcome of quantum chaos, then it is not unique to us. Just as life may have sprouted elsewhere in the universe, so too might awareness. Perhaps in distant galaxies, or in universes beyond our own, entirely different forms of consciousness have arisen, shaped by physical laws and evolutionary paths alien to us. They may not think in words or see in images or feel in emotions the way we do. Their awareness could be utterly unlike ours, and yet still be a window through which the universe experiences itself. This possibility reframes the age-old question of whether we are alone. Even if no other minds share this particular cosmos, the multiverse, if it exists, could be teeming with awareness in countless forms. In some universes, perhaps consciousness flickers for only a brief geological instant, as it may in ours. In others, with different laws of physics, it might persist for trillions of years or even indefinitely. The thought is staggering, not just one self-aware universe, but perhaps an endless ocean of them, each sparkling with its own kind of reflection. And yet all of this still circles back to the same mystery we began with. What is it really to be conscious? Science can describe the brain in exquisite detail, mapping neurons and measuring electrical activity. But the hard problem of consciousness, the question of why those processes feel like something from the inside, remains unsolved. It may be that the universe, in granting itself this fleeting window of awareness, has created a puzzle that even it cannot fully solve. But perhaps the point is not to solve it, but to live it. To recognize that we, improbable and fragile as we are the universe experiencing itself in this one brief moment before silence. to savor the strangeness of being awake in a cosmos that need not have produced wakefulness at all, to marvel at the fact that out of quantum fluctuations and improbable alignments, we arose not just to survive, but to ask questions that stretch into the infinite. And so as we stand beneath the stars, aware of ourselves and of the vastness around us, another question emerges. If awareness can arise here by chance, then surely it could arise elsewhere in other times, in other universes. Consciousness may not belong to us alone. It may be one of the universe's many experiments repeating in forms we cannot yet imagine. If that is true, then the question is not just whether the universe knows itself through us, but whether across the endless expanse of possibility, it knows itself in countless other ways too. Imagine for a moment that the rules of reality were not what we know them to be. What if light had no universal speed limit? What if gravity, instead of pulling matter inward, pushed it apart? What if electrons carried twice their charge, or if the strong nuclear force were only half as strong? These questions sound like stuff of wild science fiction, and yet they are not entirely divorced from serious physics. In the framework of the multiverse, each bubble universe might be governed by a different set of physical laws. Some of those universes would be bizarre, chaotic, or instantly self-destructive. Others might linger in forms both alien and fascinating, with structures and phenomena that our imagination struggles to grasp. In our universe, the physical constants, the speed of light, the gravitational constant, the charge of the electron, the relative strengths of the four fundamental forces are exquisitely balanced. Change any of them by even a tiny fraction, and the universe as we know it would unravel. Stars would fail to form or collapse too quickly. Atoms might not bind into molecules. Chemistry, biology, consciousness, everything that makes our existence possible would vanish before it began. This delicate balance is sometimes called fine-tuning, and it is one of the great puzzles of modern cosmology. Why does our universe have just the right numbers to allow for life? Is it a miracle, a coincidence, or simply inevitable, because we could only ever find ourselves in a universe where life is possible? The multiverse offers one explanation. If there are countless universes, each with different laws, then most will be sterile, silent expanses where nothing of interest happens. But by sheer probability, some fraction will stumble upon the right recipe for stars, planets, and eventually living beings. We find ourselves in one of those rare, lucky universes, not because it is special in any absolute sense, but because it is the only kind of universe in which observers like us could exist. This reasoning is sometimes called the anthropic principle. It does not so much explain why the constants are what they are, as it explains why we should not be surprised to see them fine-tuned. If the rules were different, we would not be here to ask the question. And yet beyond this logical framework lies the imaginative leap into the unknown. Consider a universe where light travels instantly with no upper limit on speed. In such a cosmos, causality might break down. Events could influence each other with no delay, past and future bleeding into one another. The very idea of time might lose meaning or unfold in ways so foreign to us that our minds cannot fully picture it. Or imagine a universe where gravity repels instead of attracts. Matter could never clump into stars or galaxies. Instead, particles would scatter endlessly, a perpetual dispersal with no structure larger than dust. To us, such a place would seem desolate and void. But perhaps under those strange conditions, entirely new forms of order might emerge, patterns of energy or fields of information that play the role life plays here. Other universes might take shapes we can barely hint at with metaphors. If the electromagnetic force were stronger, atoms would be smaller chemistry, sharper and faster, possibly leading to hyper-dense forms of matter and perhaps forms of life with equally compressed complexity. If the weak nuclear force were weaker, stars might burn differently, changing the cosmic clockwork of element production, altering what ingredients are even available for life. If dimensions were arranged differently, say if space had 4 or 5 large dimensions instead of 3, the mathematics suggests stable planetary orbits might be impossible, and gravity would behave in ways utterly alien to our experience. And yet perhaps under those rules something we would not recognize as life could still thrive. The thought is dizzying. Each variation creates a new stage, a new play of possibility, and we are just one performance among an unfathomable number. Our universe, with its blue skies and galaxies spiraling in the night, is one story. Another universe might have no skies, no galaxies, no light at all, just endless fields of energy rippling forever. Another might be born, flare brightly for a fraction of a second, and vanish into nothingness. Another might last trillions upon trillions of years, its physics forbidding decay, stretching time into an eternity where life, if it arose, could continue almost endlessly. These speculations do more than stretch our imagination. They also humble us. If reality is not singular but plural, then what we call the universe is not the stage, but just one stage among many. Our sense of importance shrinks in proportion. We are not only small within our own cosmos, dwarfed by galaxies and voids, but perhaps also insignificant in the grander landscape of existence, just one outcome among a sea of alternatives. And yet this realization carries a strange comfort as well. For while it makes us seem less central, it also places us within a larger tapestry of possibility. We are not isolated, not unique in the absolute sense, but part of a vast experiment of existence itself. Of course, we cannot observe these other universes directly, at least not yet. They remain for now in the realm of theory, mathematical models, and imagination. But even their hypothetical existence forces us to rethink what we mean by reality. If countless other realities exist, all as real as our own, then ours is not the whole of being. It is simply one version, one layer, one thread in a woven fabric without end. That thought can be unsettling because it undermines the instinct to think of our world as the world. But it can also be liberating, suggesting that reality is bigger, stranger, and richer than we can ever fully grasp. This leads to a difficult question, one that cuts deeper than physics into the roots of philosophy. If there are infinite possible universes governed by infinite sets of laws, then which of them counts as real? Is reality defined by what we can observe, or does it exist regardless of whether we witness it? Are we justified in calling this universe the true one, simply because it is the one we inhabit? Or are we like travelers in a vast library, merely standing inside one book, while countless others wait unread on the shelves? The notion of strange universes, each playing out under its own rules, stretches our perspective in ways that are both exhilarating and disquieting. It reveals how fragile our own circumstances are, how much depends on the precise alignment of invisible numbers. It shows us that what we call laws of nature may be local customs, rather than universal decrees, arbitrary features of this bubble in the quantum sea. And it invites us to imagine, if only for a moment, the breathtaking vastness of possibility beyond. In the end, perhaps the true gift of thinking about these strange universes is not in predicting them, but in seeing our own with new eyes. To realize how precarious and unlikely it is that we live in a cosmos where stars shine steadily, where atoms bind into molecules, where chemistry builds complexity, and where consciousness has the chance to awaken. Against the backdrop of what could have been chaos, void, impossibility, the fact that we are here at all becomes even more extraordinary. And yet this realization presses us toward the next question, one we cannot easily avoid. If so many realities are possible, if what we call the universe is just one scenario among uncountable others, then what is the nature of reality itself? What does it mean to be real when the very rules of the game might shift from one bubble to the next? What do we really mean when we say something is real? The word itself carries the weight of certainty, a sense of grounding, a confidence that what we perceive with our senses corresponds to something solid and external. Yet modern physics and philosophy alike whisper a much more unsettling possibility that what we call reality might be only a sliver, a paper-thin slice cut from an incomprehensible ocean of possibilities. We live inside that slice, convinced of its permanence, while in truth it might be one among countless others. Quantum theory gives us a window into this strange idea. According to certain interpretations, every potential outcome of a quantum event exists, simultaneously woven together in a grand superposition. When we make a measurement, or simply when we observe, one of these possibilities is selected for us, and the others seem to vanish. But they do not necessarily disappear. Instead, they might branch into parallel threads of reality just as real as ours, but inaccessible to our awareness. The familiar, coherent world we experience is then not the whole tapestry, but only the single strand we happen to be traveling along. If this is true, then our everyday perception of stability may be nothing more than a byproduct of how consciousness filters the underlying chaos. Our brains evolved not to glimpse the full quantum haze of existence, but to carve out a manageable, continuous narrative. Reality in this sense becomes less like a solid foundation and more like a collectively sustained illusion, one that convinces us of its permanence, even though it may be fragile and conditional. We navigate this illusion effortlessly, much as we do a dream while we are inside it, unaware that the deeper truth lies outside the boundaries of what we can perceive. Think for a moment about how dreams feel. When we are dreaming, the world around us seems convincing, even inevitable. The objects have weight, the conversations flow, the landscapes extend into convincing distances. It is only when we wake that we realize the fragility of the dream, how easily it dissolved back into the void from which it came. Some philosophers and physicists suggest that waking life itself may not be so different. What we call the real world could be a kind of shared dream, arising from the peculiar constraints of quantum mechanics and filtered through the limited apparatus of human consciousness. This idea does not mean the world is meaningless, or that we can walk through walls simply because we decide they are illusory. The laws of physics, as we experience them, are consistent and rigid, not because they are the only possible laws, but because our version of reality has stabilized into a particular pattern. Imagine standing in a vast library filled with infinite books. We happen to be reading one story, one consistent narrative with its own rules and characters. The other books are just as real, just as complete, but closed to us. Reality, then, is less a singular truth than it is a specific storyline, one path through an unthinkable maze of alternatives. This line of thought carries unsettling implications. If what we call real is only a branch among many, then the events we live through may not be unique. In some sense, there could be other versions of us walking down other paths, inhabiting different realities with different outcomes. From our perspective, those branches are invisible, unreachable, as though they did not exist. But from the perspective of the greater whole, the totality of all possibilities, they are as real as the one we know. What then anchors our sense of identity? Are we the product of one branch alone, or are we echoes of a larger self that exists across all the possible worlds? Such questions shake the very ground under our feet. They force us to re-examine the confidence we place in stability, in permanence, in the solidity of existence. Reality seen in this way becomes a moving surface like the skin of water rippling in the wind. To us it feels solid enough to stand on, but in truth it is delicate and ever-changing. Consciousness plays its role here as well, because it is through our awareness that reality becomes real to us. Perhaps we are not passive observers of the universe, but active participants in shaping which version of reality we inhabit. In that case, what we experience as the stable world may be the outcome of countless choices, countless acts of perception, collapsing the possibilities into the narrative we now call home. One way to think about this is through probability. Imagine rolling a die, but instead of a single outcome, every possible face of the die manifests in its own reality. To us, only one number is revealed, and that number defines the direction our story continues. But in the broader picture, all the numbers exist, each one leading to a branching universe. From this perspective, the sense of finality we assign to events is misleading. What we call the past might simply be the thread of outcomes we have followed, while other pasts unfold elsewhere, invisible but equally valid. The consequences of this view are both thrilling and terrifying. On one hand, it suggests that reality is far richer than our senses. Allow us to grasp, filled with hidden depths and untold variations. On the other hand, it strips away the comfort of solidity, the reassurance that the world around us is fixed and dependable. It hints that existence itself is provisional, a shimmering mirage, sustained only by the act of consciousness moving through it. And if that is true, then what we cling to as reality may be no more durable than a dream destined one day to dissolve into silence. Yet even if reality is an illusion of stability, it is an illusion that matters. Dreams may be fragile, but while we are inside them, they feel alive, vibrant, and consequential. In the same way, the shared reality we inhabit shapes our choices, our relationships, our understanding of ourselves. It provides a stage for meaning, even if the stage itself is more fragile than we dare to admit. In this sense, the illusion of stability may not diminish the importance of our lives, but rather amplify it. For what could be more precious than a fleeting moment of coherence in a sea of uncertainty? Seen this way, reality becomes both humbling and miraculous. It is humbling because it reminds us that what we call truth might be only one version, one fragile construct within an infinite ocean. But it is miraculous because it reveals that we have the capacity to experience it at all, to be conscious within this fleeting dream, and to ask questions about its nature. That we can even wonder whether reality is real is itself a marvel, a sign that whatever the deeper truth may be, our awareness is part of it. And so if reality is only a thin slice of possibility sustained by the fragile filter of perception, then perhaps we should cherish it all the more. Every sunrise, every conversation, every fleeting thought becomes part of the dream we share. And while we cannot know what lies beyond the boundaries of this branch, we can recognize the strangeness and the wonder of living within it. For if the illusion of stability is all we have, then it is not just an illusion. It is the very fabric of our experience, the fragile but beautiful stage on which existence unfolds. This brings us to a natural question, one that grows sharper the more we reflect on the fragility of our reality. If what we call existence is itself a kind of illusion, a dreamlike construct of probabilities collapsing into coherence, then what about the flow of time that seems to carry us forward? Could it be that time itself is no less illusory, no less fragile than the reality it appears to structure? What is time, really? We speak of it as though it were a river, always flowing in one direction, carrying us from the past to the present and onward to the unknown future. We imagine ourselves standing on its banks, watching the water rush by, or perhaps drifting along with it, powerless to resist. Yet physics tells us a very different story, one that undermines this intuitive picture and suggests that time may not be a river at all. Instead, it could be an illusion, a construct of our minds, designed to make sense of the chaos, or simply a coordinate in a larger geometry of reality. Einstein's theory of relativity revolutionized how we think about time. It revealed that time is not an independent universal ticking clock, but a dimension inseparably bound to space, creating what we now call space-time. In this view, the past, present, and future all coexist as part of the same vast structure, like pages in a book already written. We flip through the pages one by one, experiencing them in sequence. But the story itself, every sentence, every event is already there. Our sense of flow is not a feature of time itself, but of consciousness traveling through it. This idea can be deeply unsettling because it means that the moment you are living right now is not happening in some privileged sense. It is simply one slice of the block universe already etched into the structure of space-time. The birthday you celebrated 10 years ago, the conversation you will have tomorrow, the final breath you will one day take according to this view, they all exist together side by side as real as one another. It is only our subjective awareness that creates the illusion of moving from one to the next. Consider the analogy of a film reel. Each frame is static, a frozen image. When projected quickly enough, the sequence of frames creates the appearance of motion and continuity. To the characters inside the film, events unfold one after another with a beginning, middle, and end. But to someone holding the reel, the entire story already exists, every frame accessible at once. Perhaps time works in much the same way. We, the characters, experience one frame at a time, while the universe as a whole contains them all. If this is the case, then our deep emotional connection to time, the longing for the past, the fear of the future, the desperate desire to hold on to the present, rests on a misunderstanding. The past has not disappeared into nothingness, and the future is not waiting to be born. Both are as real as this moment, just not accessible to us in the way we expect. Our minds, wired for survival and decision-making, string these slices into a coherent narrative, giving us the impression of a flowing river where perhaps none exists. Some physicists push the idea further, suggesting that time may not exist at all at the most fundamental level. In certain formulations of quantum gravity, the equations that describe the universe do not require time as a fundamental variable. Instead, what we perceive as time might emerge from relationships between events, from changes in states, rather than from a universal clock. In other words, time could be an emergent property, not a building block. Like temperature or pressure, it arises only when many smaller interactions are considered together. For individual particles, the concept of before and after may be meaningless. This raises profound questions about identity and existence. If all of time already exists, does that mean our choices are predetermined? Our lives already set in stone? Or is there still room for genuine novelty and freedom within this frozen structure? Some interpretations argue that while the block universe contains every possibility, our conscious path through it is what selects the story we live. In this sense, time's illusion is not a defect, but a necessity, a way for consciousness to make sense of an otherwise incomprehensible whole. Philosophically, this challenges the very meaning of change. We feel that the universe evolves, that stars are born and die, that civilizations rise and fall. But if all moments coexist, then change is not happening, but simply is. The universe becomes a vast sculpture rather than a dynamic play, a timeless arrangement in which every event is fixed in place. We experience that sculpture piece by piece, convinced of the unfolding drama, while in truth nothing ever truly moves. This perspective can be either comforting or terrifying. Comforting because it implies that nothing is ever truly lost. The laughter of childhood, the embrace of a loved one, the moments we wish could last forever, they still exist, preserved in the fabric of space-time beyond the reach of decay. Terrifying because it also means that the suffering we endure, the tragedies we witness, the inevitable end of our lives, those too are eternal, inescapable, carved into the geometry of existence. But what about the arrow of time? The undeniable fact that we remember the past, but not the future, that entropy seems to increase, that eggs break but never unbreak. Physics provides a partial answer here. The arrow of time may not be built into the universe itself, but into the conditions with which it began. The Big Bang set the stage with an extraordinarily low entropy state, and everything since then has been a gradual slide toward higher disorder. Our experience of time's flow may be a reflection of that entropic gradient, a byproduct of the universe's initial conditions rather than an absolute law. This idea circles us back to the most intimate level of our own existence. Our brains are machines of memory and prediction. We string moments into stories, anchor ourselves in a past we can recall, and orient ourselves toward a future we can imagine. If time is an illusion, it is one our biology cannot afford to see through, because survival depends on anticipating what comes next. The brain's narrative may not reveal the truth of time, but it gives us enough of a framework to navigate our lives. Without it, meaning and coherence would collapse. And yet, even knowing that time might be an illusion does not stop us from feeling its pull. We still mourn the past, worry about the future, and crave permanence in a fleeting world. Perhaps the value of understanding time's illusory nature is not to escape those feelings, but to deepen our appreciation of them. To know that each moment is both fleeting and eternal, both illusory and real, is to hold life with a new kind of reverence. If time is not what we think it is, then the end of the universe, the great unraveling we sometimes imagine, may not be what we fear either. For how can something end if all of its moments exist forever? The heat, death of the cosmos, the collapse of galaxies, the fading of stars, these are frames in the real, chapters in the book, sculptures in the timeless structure. They exist, yes, but so do the beginnings, so do the golden ages, so do the moments we hold dearest. The illusion of flow may conceal the permanence of the whole, and so we are left with a paradox. Time feels like the most immediate, undeniable aspect of existence, yet it may be the most deceptive. It carries us along, or so it seems, while in truth it may not be carrying us anywhere at all. What we call time might be nothing more than the mind's way of ordering an unfathomable reality into a story we can survive inside. But if that is true, then the real mystery is not just time itself, but what it means for the universe to have an end. For if time is an illusion, what does it mean for anything to ever truly be over? Every vibration must eventually come to an end. That is the inescapable truth of music of life, and it seems of the universe itself. The cosmos we know, brimming with stars, galaxies, planets, and fleeting sparks of consciousness, feels infinite when we look up at the night sky. Yet physics insists it is temporary, a performance destined for silence. The universe began with a sudden surge of energy, a great wave rising from the sea of quantum fluctuations, but waves do not last forever. They crest, they ripple, and then they fade back into stillness. Scientists have long wrestled with what this fading will look like. One possibility is the Big Freeze. Imagine a universe that keeps expanding faster and faster as dark energy drives galaxies apart. Over trillions of years, stars exhaust their fuel, galaxies grow dark, and black holes themselves evaporate through Hawking radiation. What remains is an endless expanse of thin, cold emptiness, a sea of scattered particles stretched so far apart that they never meet again. It is not a violent end, but a gradual slipping into silence, the cosmic equivalent of a candle burning out. Another possibility is more catastrophic, the Big Rip. In this scenario, dark energy does not just accelerate expansion, it grows stronger, tearing galaxies apart, then solar systems, then planets, and eventually atoms themselves. Reality unravels from the largest scales to the smallest until there is nothing left but a soup of fragmented spacetime. The universe, once a majestic tapestry, would be shredded, thread by thread, in a final act of destruction. And then there is the most unsettling possibility of all, vacuum decay. According to some interpretations of quantum field theory, our universe may not exist in the most stable possible state. Instead, we may inhabit a false vacuum, a precarious energy configuration that appears stable, but could collapse without warning. If that were true, a bubble of true vacuum could form somewhere in the cosmos and expand at the speed of light, rewriting the laws of physics as it spread. Inside that bubble, everything familiar, particles, forces, even the structure of space-time would vanish, replaced by something utterly alien, or perhaps by nothing at all. From our perspective, it would be instantaneous. One moment we exist, the next moment we do not. Each of these endings paints a different picture, yet they all share one feature: silence. Whether through freezing emptiness, violent tearing, or sudden collapse, the universe we know will not last. No stars will shine, no atoms will bond, no minds will wonder about their place in the cosmos. Only stillness will remain, a quiet return to the background quantum sea from which everything emerged. The oscillations will have stilled, the cosmic music ended. It is difficult to grasp the weight of this thought. We tend to see ourselves as small but part of something eternal, a universe that will outlive us by countless ages. Yet physics suggests that even the universe itself is mortal. That recognition is sobering and for some terrifying. If everything ends, if every story closes, if even the grandest structures fall to silence, what meaning can our brief existence possibly hold? Paradoxically, this awareness of fragility may be the very thing that gives meaning to life. The fleeting nature of the universe mirrors the fleeting nature of our own lives. Just as the cosmos will one day fall silent, so too will we. And just as that silence does not erase the beauty of the cosmic symphony, our mortality does not erase the beauty of our moments. On the contrary, Impermanence sharpens our awareness, urging us to value what is here now before it is gone. Imagine watching a sunset knowing it will be the last you ever see. Every color becomes sharper, every second more precious. In a sense, that is our position within the universe. Every star we glimpse, every thought we form, every act of kindness or love we share exists against the backdrop of impermanence. It is precisely because the cosmos is temporary that our experiences shimmer with significance. The poet Rainer Maria Rilke once wrote, "Beauty is nothing but the beginning of terror." Perhaps he intuited what physics now tells us, that the beauty of existence lies not in its permanence, but in its fragility. The universe will end, and yet here we are alive, in one of its rare moments of light and warmth. To dismiss our lives as meaningless because they are temporary is to miss the point entirely. The fleeting spark is meaningful because it is fleeting. And yet there is another perspective worth considering. Even if our universe ends, even if the vibrations die out here, might they begin again elsewhere? The multiverse hypothesis suggests that new universes could bubble into being from the quantum sea, each with its own laws, its own possibilities, perhaps its own fleeting sparks of consciousness. If so, the death of our universe is not the death of existence itself, but one note in an endless cosmic symphony. We will not see the new notes, of course, but knowing they might exist reframes the silence not as final, but as transitional, the pause between movements in a larger composition. Still, the fact remains for us here, and now the universe is fragile. The knowledge of its eventual stillness can either paralyze us with despair or awaken us to wonder. Every moment becomes both insignificant and infinitely valuable, a paradox we must learn to live with. The atoms in your body forged in ancient stars will one day disperse into the silence, yet the fact that they came together at all, long enough to think, to feel, to wonder, is extraordinary beyond measure. When we accept that the universe itself will one day fade, we are left with a choice. We can see it as a cruel joke, a reminder of futility, or we can see it as a call to live fully in the present, to create meaning where silence threatens. The end of the universe makes love more important, not less. It makes kindness more urgent, not less. It makes the simple act of being alive a miracle, not a given. So yes, one day the vibrations will settle. One day the cosmic song will end. But for now, we are here within the music. We are notes in the grandest melody ever played, brief but irreplaceable. And perhaps the best way to honor that truth is not to mourn the coming silence, but to listen fully and deeply while the music lasts. And this brings us to the most personal of questions. If the universe is only a temporary oscillation, if everything we know and love is destined for stillness, how then should we live? A flower blooms radiant for a brief season, and then withers. Its beauty is not diminished by its impermanence, but heightened by it. We cherish the blossom precisely because it cannot last, because its fragility invites us to look closer, to notice, to be present. In many ways, the universe itself mirrors that flower. It bloomed from nothing, filled with light, stars, and life, and one day it too will fade. But this fleetingness does not strip it of beauty. It may be the very reason beauty exists at all. If we accept the idea that our universe and everything within it is temporary, a brief fluctuation in an infinite sea of possibilities, then our lives take on a startling clarity. We are not infinite beings, not eternal witnesses. We are sparks quick to appear and quick to vanish. And yet in those sparks lies meaning. Each heartbeat, each conversation, each discovery is a jewel strung along a thread that exists for only a short while. It is a necklace that will eventually scatter, but while it is whole, it glimmers with impossible wonder. Think of the night sky. The stars we see are already ghostly reminders of what once was. Many have already died, their light still crossing the gulf to reach us. Every glance upward is a lesson in transience, yet we find that knowledge comforting rather than devastating. We look at starlight from centuries past and feel awe, not despair. Why? Perhaps because deep down we know that the temporary does not diminish worth, it creates it. The same is true of human relationships. Friendships that last a summer, loves that last a decade, bonds that survive for a lifetime, all are impermanent. People change circumstances, shift time pulls us apart, and yet none of that erases the value of the moments we shared. A smile, a kind word, a shared silence under the stars, these do not need eternity to matter. They matter because they happened, because they colored the brief canvas of existence with warmth and connection. Even in science, in the very pursuit of understanding, we see this principle. Every discovery is temporarily destined to be refined or replaced as knowledge grows. Theories are provisional. Models are imperfect equations, hold only until deeper ones supersede them. But this does not diminish the work of generations. Each step is a pearl of understanding, a fragment of clarity in the sea of uncertainty. Just as a flower's beauty is not lessened by its brevity, a scientific insight is not lessened by its impermanence. It remains a moment of illumination in the dark. To view impermanence as tragedy is to miss its hidden gift. Imagine if nothing ever changed, if all was static, eternal, unyielding. Beauty would vanish, for beauty relies on contrast, on the play between presence and absence, growth and decline, emergence and fading. A sunset moves us because it is slipping away even as we watch it. A song resonates because it ends, leaving silence in its wake. Without endings, beginnings would lose their meaning. Without loss, joy would lose its sharpness. There is a quiet wisdom in traditions that embrace impermanence. In Japanese aesthetics, the concept of mono no aware refers to the bittersweet awareness of life's passing moments, a gentle sadness that deepens appreciation. A cherry blossom drifting to the ground is beautiful not in spite of its falling, but because of it. The fall reminds us to cherish the bloom while it lasts. Perhaps the universe itself is a grand cherry blossom blooming for a cosmic instant, reminding us to treasure our place within it. This perspective transforms how we see our brief existence. Instead of despairing that we cannot last, we can marvel that we exist at all. The odds of life emerging of consciousness, awakening of a being capable of wonder arising in the chaos of physics, are unimaginably small. And yet here we are. In this improbable, fragile, fleeting universe, we think, we feel, we create meaning. That is not a failure of eternity. That is a triumph of the moment. Even pain and loss take on a different texture under this light. Grief is sharp because what we loved was real and because it ended. But grief is also proof of love, of connection, of shared existence in a brief and precious window. Without impermanence, we would never have cause to grieve, but without impermanence, we would never have had cause to love in the first place. The cosmos is fragile, life is fragile, consciousness is fragile, but fragility is not weakness. It is delicacy, like the fine glass of a stained window catching the sun. It is transience, like morning dew sparkling before it vanishes. Fragility does not make the universe less miraculous, it makes it more. To live with this awareness is to live fully, to recognize that every moment, every gesture, every breath is a rare alignment in an endless sea of possibility. So we return to the flower. It blooms, it fades, and we remember it. We do not curse it for dying, we thank it for being. Perhaps we might learn to see our universe and ourselves the same way, to hold each other as blossoms in the vast cosmic garden, fragile and fleeting but breathtakingly beautiful, to see our lives not as failures of permanence, but as gifts of the temporary. And so when we ask why there is beauty in impermanence, the answer may be simple. It is because impermanence is what allows beauty to exist at all. Every laugh, every star, every discovery, every love is a miracle precisely because it does not last forever. And in this miracle we find not despair, but gratitude. Which brings us to the final question, the one that circles back to ourselves. If impermanence is the heart of beauty, if we are fragile sparks in a fragile cosmos, then what does that say about us? These strange creatures who not only live within impermanence, but who pause to contemplate it, to weep for it, to celebrate, to it to find meaning. in its fleeting glow. Perhaps the universe is nothing more than a ripple in the fabric of possibility, a brief oscillation that rises from nothing and will one day sink back into silence. That thought can feel dizzying, almost unbearable, like staring over the edge of a cliff into an infinite abyss. But here is the secret that lies quietly at the heart of such a question. The final truth is not contained in equations or theories, not in the language of physics or in the diagrams of cosmology, but in the way you feel when you let these ideas wash over you. The cosmos may be vast and impersonal, but the experience of it is intimate, personal, unrepeatable. Science carries us to the very frontier of knowledge. It hands us extraordinary tools to measure, to model, to predict. It reveals galaxies spinning billions of light years away, particles that exist only as probabilities until observed forces that shape the architecture of all things. Yet no matter how far it goes, there is always a boundary, always a place where certainty fades and mystery remains. Beyond that edge, science cannot command, it can only gesture. It is there at the threshold that philosophy, imagination, and individual choice step forward. Some look into the vastness and feel overwhelmed. They see their lives as grains of sand in a limitless desert, fragile and insignificant. The temporary nature of everything, of stars, of civilizations, of memories, can weigh heavily. Others gaze into the same vastness and feel peace. To them, impermanence is not a curse but a relief, a reminder that nothing is fixed, that even suffering and sorrow will pass, that every joy is precious, precisely because it is finite. Both responses are human, both are valid. The universe itself does not dictate which one you must adopt. That choice belongs to you. There is something quietly miraculous about that choice. Imagine for a moment what it means. You, a being made of stardust, assembled by chance through billions of years of evolution, can pause to consider your place in the cosmos. You can feel wonder, fear, gratitude. You can decide whether the story you tell yourself about existence is one of despair or of celebration. No law of physics forces your conclusion. No equation determines whether you feel small or infinite. The freedom to interpret the universe, to craft meaning from its silence, is itself an astonishing gift. Think about it right now. You are alive, conscious, aware. That is not a trivial fact. It is extraordinary. Out of uncountable atoms and endless fluctuations here, you are able to think, to feel, to love, to laugh, to imagine. You can touch the hand of another, watch the sky glow at dawn, hear the rhythm of music, taste the sweetness of fruit, smell the rain on the earth. Every one of these experiences is a miracle, not because they defy the laws of physics, but because they emerge from them. And so the question turns inward. When you encounter the idea that the universe may be temporary, that reality itself may be fragile, that time may be no more than a construct, what do you feel? Do you recoil, or do you lean closer? Do you see emptiness, or do you see possibility? These feelings matter, for they shape how you live. If the universe is fleeting, you can choose to cling to despair, or you can choose to live as though each day is a treasure offered once and never again. Both interpretations may be true, but only one will bring you peace. Perhaps this is where science and philosophy converge. Science maps the cosmos, but philosophy asks how you will live within it. Science reveals that stars are born, burn and die, but philosophy asks how you will burn while you are here. Science tells us time may be an illusion, but philosophy asks what you will do with the moments you believe you have. Together they paint not just a picture of the universe, but a mirror held up to the soul. It is tempting to believe that one day we will find the final answer, the ultimate theory that explains everything, that erases doubt. But perhaps that belief is misplaced. Perhaps the beauty lies not in closure, but in openness. The universe may not be a problem to be solved, but a mystery to be lived. To accept that is not to surrender, but to participate. It is to dance with the unknown, to let the questions themselves become part of the meaning. In this light, your perspective becomes not just an interpretation, but a creation. By choosing awe over despair, gratitude over fear, wonder over numbness, you are shaping the story of your existence. The universe does not care, but you do, and that is enough. So perhaps the universe is only a ripple, a temporary vibration that will fade. But in this blink of eternity, it is everything. It contains galaxies and atoms, beginnings and endings, sorrow and laughter, silence and song. It contains you standing here listening, wondering. And that is the final secret. The universe is not separate from you. You are not outside of it gazing in. You are of it, an expression of its laws, a child of its chaos, a fragment of its fleeting beauty. When you reflect on it, the universe is reflecting on itself. When you ask what it means, the universe is asking through you. That is not illusion. That is not trivial. That is profound. So take this thought with you. Maybe the cosmos is only a brief oscillation. Maybe it will vanish without a trace. But while it exists through you. Your life, your choices, your feelings are not beside the point. They are the point. In this moment, you are the way the universe comes alive, the way it breathes, the way it dreams. And so let this be the ending that is not an ending. A closing thought that opens onto infinity. The universe may be brief, but it is yours. Whatever it is, however long it lasts, however strange or fragile it may be, it belongs to you now. And that is enough.